Okay, we're going to try to continue with this. Oh, I need my lights on. So this was that silly project that where I was using the LM324 to measure the light, so it does still kind of work if you cover up the light sensor. I changed the LEDs around so they make a bit more sense. Now we're at full, where it's green. The green's a bit dark. I may have the wrong... No, I think I have the right resistor. So I spent all this time trying to get one of the LEDs, for some reason, was all dark. It was quite dim when I was playing with it afterwards, and it's because I had the wrong resistor in, because I've got these two different coloured ones here, which just makes me think I'm not going to be able to do my extra bit because I don't know where I put those guys. In fact, I've kind of forgotten what they were, but that's okay. We're only going to do a very quick video with a capacitor, so we're going to lead up to the next step in this process. We don't actually have to do that. You'll see what I mean in a second. So, I wonder where I did put these things. No, it doesn't matter. It doesn't matter. What matters is we're just going to quickly change. So at the moment it's using a voltage divider. Probably should have prepared this bit. Give me a second. So that's that one. So just a reminder, there is this part of the circuit here is this sort of complicated voltage divider here going in here, and then we've got I've called it the test voltage here, but I'm going to call it VREF a bit later on. So the reference voltage is coming from a circuit which looks a little bit like this. So here's the LDR, here's another resistor. As this changes, the voltage at this point changes, and that's what we're reading into here. And if this is higher than this voltage, its output's kind of high, and if it's lower than that voltage, it output's kind of low. LM324's output actually about, so from 5 volts you get about 3.6 or something from what I'm getting. And it goes down to about ground. So it goes down to the ground, but it doesn't go all the way back up to 5 volts, but that's because we're kind of abusing this. We're not really using it the way it's supposed to be used, but it works fine for this. There we go. There's the two voltage divider sort of setups, but we're going to do something different today. Well, it's going to be kind of the same, but it's going to lead on to the next part of the project. We're going to use a capacitor instead. So we're going to create it's essentially going to work out just like the voltage, the voltage divider with the resistor. But in this case here, we've got a resistor and then we've got a capacitor. And so when we have a positive voltage here, it's going in here. This capacitor will slowly build up charge across here, and so we'll have a voltage potential difference that builds up between these two things here. So slowly, at first, there'll be no potential difference between these two plates. And so this will read 0. But as voltage comes in and builds up over here, we're slowly going to get higher and higher and higher, and eventually it will reach the point where there's a big voltage potential difference across here, and the voltage will be very high. So it will essentially, the way to imagine it is that at the very beginning, when there's no voltage, no charge stored on the capacitor, then lots of electricity will flow into it, and it kind of acts like a very low resistance part of the circuit. So it's all going out here. I'm going to go into a big long discussion on how I understand these things later on, but for now we're not going to. But as time goes on, and by time I mean pretty quickly, I'm hoping this will be like a second or something at the least. Then I'm not thinking about it, this should be a lot longer, but we're going to come to that in a second. But as it builds up, there's less and less capacity to store charge across the capacitor. So it kind of, you can imagine it building up resistance. So it's getting higher and higher in resistance. So as it gets higher and higher and higher in comparison to this resistor, so eventually it will reach the point where it's, theoretically, ideally, it's like infinite resistance, because there's no charge can cross the barrier, and there's no charge that can be stored on the plates. And so what happens is the voltage, the potential difference is across the plates, and there'll be nothing across here, because this will be a very small resistance in comparison to the effective resistance of this. That's one way of imagining it. Move that down a bit. The point being is that as it goes up, this voltage will change from being 0 and head up slowly towards the positive voltage, or 5 volts in our case here. And so hopefully we'll be able to see that on our little LED bar graph, because it will start off with no LEDs on, and then it will build up and go to here. And it will probably do it quite fast, but we're going to go through ways of making it slow. So the circuit I'm going to have is it was actually supposed to be, so you have to have, imagine that I actually remember to draw this in. I need a piece of paper, because otherwise it's going to mark the paper underneath, and I don't want to mark the paper underneath it. But there's meant to be a little switch that we're going to imagine there's a switch there. So I'm going to have a little switch. So the idea is that I can charge it up by pressing this one here. So if I press this little button, positive voltage goes through here, charges up the capacitor just like I said here. This will slowly increase. And then when I want it to discharge, I will press this button, and then this will be 0 volts, and so then the current will, the built up voltage here, or the built up potential difference here will, built up on these plates will then flow back through here down to 0 volts. So this button is connected down to ground, so these are both down to ground. And this one goes to the positive voltage. But if you don't do that, I suspect what will happen is it will discharge anyhow through the actual op amp. So this op amp isn't super high impedance or resistance for the thing, so it's still going to provide some currents going to go through there. So the LM324, I don't know how big it is. It's probably like 1 or 2 mega ohms or something. I think I saw somewhere. Probably should have printed out more of the data sheet than the one page. But hey, what are you going to do? But we'll find out anyhow, and I don't think it's going to matter too much. Like even if it does suck up some of the current as you're charging up. So when you're coming in here, some of the current's going to go through here, and so this is going to affect the actual charging. But I think it's just going to make it charge a bit slower, which is fine with me because I don't want it to charge too fast because I want it to make an interesting effect. So let's just have a look at what we're going to do. So we have to get. Just as I said that, I've gone and misplaced. Alright, well, I've got a whole box of capacitors, so we're going to use these. Oh, before I actually do it, so I'm going to try and work out. So I'm guessing how long will it take? Well, this is idea of this time constant thing that I've seen, and I wanted to see if this kind of roughly works out. So this is how long it takes for the capacitor to charge to 70% of the difference between this part and this part. So in this case here it's 5 volts difference, and so after the time constant amount of time it should have charged up to, I don't know if that's the right word, but it got to the point where this is now at 70% of the voltage between these 2 points here. So that would be around 3.5 volts or something, or 3 point something volts. And so after a couple of those it should mostly get up to about 90% of the full voltage. 90, and I think it's about like 5 time constants before it gets pretty much close to all the way up to there. So it makes it nice because it will have a nice little sort of I can't draw it in air like that because you can't see it, but like a sort of curve that looks like this. So it's not a straight line, which I'm hoping will make for the final project a nice, we can sort of rig it so that it has a nice effect. But I'm not going to say what I'm talking about yet because that's going to give away what I'm trying to build. So anyway, I'm going to use a 10 microfarad to start off with, and this 100 kilo ohm resistor here. So these are going to be my two little components. And so I don't know if I got the maths right, to be honest, because I'm not very good. So 10 microfarads is 10 times 10 to the negative 6 farads. Because you have to have these in similar kind of units. So it would be okay if I was using milliohms and millifarads, but if I'm using microfarads and kiloohms, I'm going to have to write them out in terms of just ohms and farads to get the maths right. So this is 10 times 10 to the negative 6, which is 10 times 10 to the negative, which is 1 times 10 to the negative 5. I know, but I'm going to do it this way. And 100 kiloohms is 100 times 1,000, which is going to be 1 times 10 to the 5th, 10 to the 5. So there's 5 zeros, and then there's 6 zeros back before the decimal point. I don't know if I'm doing it the right way here. Yeah, before the decimal point, and then we're going to times it by 10. So we're going to move there. So the idea is, if I multiply those two together, which is that one times that one, so it's 10 times negative 10 times 10 to the negative 6 times 1 times 10 to the negative 10 to the positive 5, then that's 5 plus negative 6. So that's 10 times 10 to the negative 1, which is just 1. So that's basically 10 divided by 10, which is 1. So 1 second. So it should be about 1 second. So we should at least get a reasonable effect that we can actually see, if I've got this right. So so we should see 3 of the LEDs lit in 1 second, and then the last one will get lit just after that, which is not so exciting. But we're going to play around with these values and see what we come up with. So I don't know where I'm going to put this thing on this board. I'm going to guess I'm just going to put it over here. So we're going to have to make this, and remember these are polarized, so they've got a little negative sign. And I haven't wired all the wires up to here, have I? Why is this wire even here? It's not even connected to, oh, it's over here. Right. Okay, so I'm just going to be lazy, and I'm going to stick that one straight into the negative rail, which is connected via that. And then I'm going to put this one, I'm going to be real lazy. So we're not going to make a neat and tidy board. So the only problem with this is that straight away we have to use the buttons, don't we? Let's do, I don't want to put in another board. We have to put in another board because it makes it easier to see. And where did I put my little bag of little buttons I just bought? So we're going to have a lot of extra wires. I hope I know where I put all my spare wires. I think I did there. Oh, we just have to use those ones. Okay. Mumble, mumble, mumble. Now, these are not so easy to put. I don't have to put them in that way, do I? I am going to put them in that way. Okay, that's one button. So that's the on button and the off button, in theory. And we're going to take this off, and now it's all charged up. Or it might be charged up. It doesn't matter. So where's my little picture? Alright, so this is going to be we're just going to put that straight to negative. Alright, so that one's going there, and then I need a little wire to connect these things up. So I think I can just do it this way, can't I? I hope so. Alright, so those are, that's that connection there. So I built that one. That looks so nice. That looks so much nicer than my normal monstrosities that we've got over here. And now I just realized that I'm going to need two 100 kilo ohm resistors. But that's okay, because I've got a pile of them. But I don't have any fancy old ones. So I've been putting spare resistors inside of business card packs. I don't know if that's a very good way. I'll just take out, I think I've gone and completely misplaced the one I just had a second ago. So I'll just take out two more. I don't have any old school 100 kilo ohm resistors, at least I don't think I do. And so I've got these thinner ones, which I don't really like. And so all I'm going to do is I'm going to stick that one, this was the on button one, wasn't it? So I want to try and get it so they're all on the same side. Which is going to make it look super ugly. So I went to all that nice effort of making it look neat and tidy, and now I've made it look ugly. So that one's the positive rail one. This one's going to go to the negative rail. It's not working. You could actually just do. Ooh, is that in? That's what I don't like. I think that's in. Okay, and now we're going to need three little wires. What am I taking apart? I'm taking apart something important. So what is this thing? I think this thing is my old LM324. So I probably should have just turned that one on, and you could have seen what it did. Okay, so green for positive. That makes sense. Why don't I just use the red one I had over here? Actually, why don't we just stick... Where's the best place to attach this thing? well, here. No, that's the wrong way around. Okay, it's in. We're going to move those two along. Look, it still works fine. The wonders of computers. Okay, it's not even a computer. Okay, and is that going to fit across? It is. Look at that. That's nice and, well, that always feels like it's just slightly too short. Okay, so now we have on the wrong side, whoops, the positive. So we'll just do that. Negative. I'm going to turn it off for a second because I don't trust myself to do this correctly. Alright, so now it's all kind of set up. So what did I use? So one over here, there's a, from last time, there was a particular wire that was the voltage reference wire. So, which is this black one here. So all we have to do now is take this black wire and plug it into here. And then when we turn it on, there's a light on. That's not what I wanted. Oh wait, it is charging up. It's a lot slower than I thought. Well, I got that wrong, so it must be like 10 seconds. Is it going to get all the way to the top? It is! We did it! It's all the way. That green one's not very impressive. I feel like I should replace that green one with... So if I let go, it will slowly discharge through the op-amp. And go back down. But if I press this one, it will discharge faster. Why can't this one turn off? That's interesting. I'm just going to change this for a second because the blue ones look so much more fancier. Alright, charge it up, and so this is a problem because I want this one to go out. And I have wired it up correctly, haven't I? Well, I can just test if I go to... I've done something wrong because if I go straight to ground, that one just stays on all the time. So now what have I done? We're so close to getting this to work, and now there's a little quirk in this thing here. So it's probably to do with... Wait a moment. That's actually just plugged straight in. That would explain why. It's just plugged straight in. So I think it was meant to go in there. And now I've got to plug it back there. Now that's the way we want it to go. And then we can turn it off. So for some reason I plugged it into the positive rail. So that's not so good. So now it kind of works. It turns off, turns on. So charging up, turns off. And so that's quite funny, isn't it? And if we put in a larger capacitor, it is a fun way to say it, capacitor, oops, then it will take a lot longer to charge up. So if I hold it, I'm going to have to hold it down for a while. We're up to 1. And we're going to take, so it's going to take 10 times longer because this is a 100 microfarad. And so you can, that's the nice thing about that maths. It's like the easiest maths in the world, right? Because if you're increasing one of those things by 10, then the answer increases by 10 because it's just a simple multiplication. And then we're going to take forever to get back down again. But the problem with that, I'm just going to go get one of my fancy new things. Oh, what did I knock over? Turns out I did in fact get a big box of relatively old school 10K resistors. So what I like about this way of doing it, of course, is that there's 2 different resistors here. So you don't have to charge and discharge at the same speed. So we're not going to charge and discharge at the same speed. We're going to, I'm pretty sure I can do it on the other side. That looks a lot neater. I always get a little bit confused about how the buttons are wired up. So now I can discharge it. So now I can slowly charge it up. Very slowly. And And then we can discharge much faster because I've got the lower resistance. So this is a 10 times smaller resistor, and so that's going back to basically what we had before. So again, I've reduced the time constant by 10, a factor of 10. I don't know if that's a great way of saying it, and so that one goes down faster. So that's nice. But anyway, so the next step on this little process, taking a very long time of doing this. Well, the next thing I'm going to do it on the, I was actually going to do it in this video, but I run out of time. I'm going to rearrange this. So I'm going to add in 2 more LEDs. The final project is going to have 8 LEDs. And then we're going to work out a way, but we're going to do we're going to use 2 LM324s, and we're going to add 2 of those op amps, and the second one are going to be used for 2 more LEDs, but the other 2 are not going to be used to light up LEDs. They're going to be used for a slightly different purpose, but they're very similar purpose. And so we're going to increase this a fair bit, and then we're going to use an IC to do the automatic switching. So at the moment I'm having to press the button to charge it all up. I'm getting a bit tired of that. It was much more fun when it was faster. And so to charge it up, it's going to zoom down now. Woo! Woo! Can you even see this? I hope you can see this. So it's much faster going down. We're going to do this automatically. So the idea is it's going to build up and then go down, build up and then go down, build up and then go down, which is going to be our first oscillator that we're going to build. And we're not going to use an LM324 in order to do the oscillator yet, but I'm hoping that in the end this entire circuit will be done using only LM324s. But we're going to introduce a new IC for the next time. So thanks for watching, and like, share and subscribe.